Good class. All right, lesson 5 starts getting a little bit more difficult. It is review of some Algebra 2 concepts, but it amps up the difficulty level. And so I'm going to go over everything that's covered in this lesson, and then if you guys have questions, I will see you on Google Meets. So I'm going to start, I like to go in the same order the book does. So it starts with 5.A, and it's a review of exponents and radicals. Now remember, radicals are basically any like root symbol. So some review for you. The square root of x is equivalent to x to the 1/2. Okay? Just like the cube root of x is the same as x to the 1/3, and so on. Okay? Some other review that's super important are some shortcuts. The square root of 3 times the square root of 3 equals 3, because you get the square root of 9, which is 3. So the shortcut, square root of 3 times the square root of 3, is technically the square root of 9. Maybe I'll rewrite how I wrote that of someone just loading this document. That's the square root of 9, which is just 3. Okay? And that is true for anything. So the square root of 6 times the square root of 6 is just going to be 6, because I would get the square root of 36. Okay, so those are some things that we're going to help you later. Okay, so I'm going to jump into an example similar to the one you will see in homework. So simplify the following: the square root of x cubed y times the 4th root of x y cubed. All right, so first things first, I have one radical times another. There is an invisible like multiplication symbol, they just don't write it. And the easiest way to do this problem is to rewrite this using fractional exponents. So I'm going to rewrite using fractional exponents. So, for example, this would be x cubed and y to the 1/2, right? Because the square root is the same as something to the 1/2 power, okay? Times xy cubed to the 1/4, okay? Because anything to the 4th root is the same as raising it to the 1/4. Now from here, I'm going to, remember, this is a review, I'm going to multiply my exponents. So x to the 3rd times 1/2 would be x to the 3/2. Right, there's invisible 1 underneath it. 3 times 1/2 is 3/2. And then y, there's only an invisible 1 here, so 1 times 1/2 is just 1/2. Times x to the, there's a 1 here, so 1 times 1/4 is 1/4. And y, 3 times 1/4 would be y to the 3/4. Okay, so in this step, I'm going to add my exponents. So that equals x to the 3/2 plus 1/4 times y to the 1/2 plus 3/4. Okay, and so I'm going to add these by creating common denominator. So this gives me x 3/2, I would times by 2, right? And that would give me 6/4 plus 1/4 times y. I got to make this one into 4, so that would be 2/4 plus 3/4. So then create common denominators. So my final answer would be x to the 7/4 and y to the 5/4. And that, my friend, is my answer. Okay? Let's try another one. Different type of problem. Way different. I'm only going to do one of each. The next one, simplify x to the -2nd plus y to the -2nd all over xy to the -1st. I'm going to move that up. Now, this is a review of negative exponents. Okay, so negative exponents I write the reciprocal and make exponent positive. I'm going to start to write in shorthand, but for now, I'll give you full. So x over -2 is really 1 over x squared plus 1 over y squared all over 1 over xy. So notice for each one I wrote the reciprocal because it had a negative power. Now this is now reviewing complex fractions. Okay, my common denominator here, the LCD here, would be x squared y squared. That's one way to do it, and I think that that is the easiest. Okay, so I'm going to multiply everything by x squared y squared. Multiply top and bottom by x squared y squared. Okay, and I get, if I multiply these, the x squareds cancel, and I'm left with y squared, plus, when I multiply these, I have a 1 underneath, the y squareds cancel, so I'm left with x squared. And when I multiply these, I should have an x that cancels. X squared over x to the 1st leaves me with x. Y squared over y is y. And you can leave it that way, or you can put it in order, but you don't have to. Okay, so you can rewrite this to be x squared plus y squared over xy. But again, I would accept this. All right, so we covered fractional exponents. We've covered complex fractions and negative exponents. Last would also be fractional exponents. So simplify 3 times the square root of 3 over 2. We're going to get into rationalizing radicals, which is super important. I'm going to make this fraction bar a little bit bigger. Minus 4 times the square root of 2/3 plus 2 root 24. So much review in this problem. Okay, so first things first, the easiest term here to simplify would be the 2 square root 24. And so I'm going to do that on the side. I'm going to simplify 2 square root 24 is 4 times 6. So that is 2 times 2 square root 6, which is 4 root 6. So this last term becomes 4 root 6. What I'm going to do with the others, I'm going to break it up. So the square root of 3 over 2 is the same as 3 times the square root of 3 over the square root of 2 minus 4 times the square root of 2 over the square root of 3. And I already simplified this term to be 4 root 6. Okay, now something I have to do here, I have to rationalize the denominator. That means that I can't leave radicals in bottom. That's all that means. And in order to get them out of the bottom, I have to multiply top and bottom by what's in the bottom. So to rationalize this, I would multiply top and bottom by the square root of 2. And to rationalize this, I would multiply top and bottom by the square root of 3. And I'm going to rewrite this. So on the top, square root of 3 times the square root of 2 is the square root of 6. Over, we covered this in the beginning of my notes. Square root of 3 times the square root of 3 is 3. Because when I multiply them, I get 9, and the square root of 9 is 3. So here, the square root of 2 times the square root of 2 would be the square root of 4, which is 2. Minus 4 root 6, right? Square root of 2 times the square root of 3 is 6. Square root of 3 times the square root of 3 is just 3 plus 4 root 6. Phew! All right, so from here, what can I do? Well, I can do a couple things, and I'm going to actually combine these by creating a common denominator. So the common denominator here is 6. So I'm going to multiply this by 3. I'm going to multiply this by 2. And I'm going to multiply this by 6. Okay. So here we go. That gives me 9 root 6 over 6 minus 8 root 6 over 6 plus 24 root 6 over 6. And now notice, those are all beautiful. And I can combine those. So 9 minus 8 is 1. 1 plus 24 root 6 over 6. And that is the final answer. Crazy stuff. Okay, the last one from this 5.A, right? 5.A is a little bit longer. Some sections are going to be so fast, you guys, and other sections are really long. I don't know why the book grouped the way they did, but it is what it is. So simplify. We're going to go over multiplying radicals. So square root of 2 plus the square root of x times 1 minus the square root of x. Okay, we're simply going to distribute. So the square root of 2 times the square root of 1 is root 2. Square root of 2 times x, that would be negative root 2x. You're multiplying by what's inside. Plus the square root of x. Square root of x times the negative square root of x is just x. Now, you can technically leave it that way because we're adding, we're not multiplying, so I don't have like bases. So this would be your answer. Okay? Moving on to 5.B is a review of complex numbers. So let's review. Complex number is the square root of negative 1, which equals I. And I know that I squared equals negative 1. So if I wanted to simplify square root of negative 5, the negative becomes I, and then I have root 5. Okay, another way to write that is root 5I. But make sure that the I is not inside the square root symbol. Okay? A complex number is in the form A plus BI. Example 2 minus root 13I. This would be called the real. This part here is called complex. Okay. So they do some examples simplifying with I, some pretty complex ones. I'm going to do 2 of them with you, and that should cover it. But this right here is super, 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 super important. We're going to use that a lot. So I believe we're on example 5. Simplify the following. 3I cubed plus 2I to the 5th minus 3I plus 2I squared. Now I'm gonna simplify in terms of I squared. Okay, so I'm gonna rewrite everything to be in terms of I squared, because I know that I squared equals a negative 1. So for this first term, I'm going to rewrite this. I cubed is the same as saying I squared times I, right? There are I cubed means there's 3 of them. And I'm going to group them in pairs of I squared. So if there's 3 i's, I have 1 here. So 1, 2, 3, right? I have a total of 3, but I know I can simplify him, and so that's why I'm going to write it that way. Plus, I know that there are 5 i's. Well, how many groups of I squareds would that be? That would be 2 groups of I squared, and you'd have 1 left over, right? I to the 5th equals I squared times I squared times I. But I'm writing him. The purpose of doing that is because these will cancel and become negative 1. I can't do anything with him, but this guy right here is in terms of I squared, so I'm simply going to multiply by negative 1. So that is when I'm going to simplify each term. I know that this is 3 times negative 1 times I, which would be negative 3I. I know this next one is negative 1 squared times I, which would be positive, right? A negative 1 squared, so this is positive 2I. This guy just comes straight on down. There's nothing to simplify. And this would be negative 2. When I write my answer, make sure it's in complex form. So the real part would go first. And negative 3i plus 2i minus 3i, I believe, gives us negative 4i. So answers need to be in complex form. Okay, so you're going to have quite a few of those. Hopefully that makes sense to you how I simplified that. So number 6. Another type of problem involving complex numbers. So simplify the square root of negative 3 times the square root of 4 plus 3 square root negative 2 square root negative 9 plus the square root of negative 16 plus the square root of positive 16. All right, so again, I'm going to simplify each of these. Remember, the square root of a negative number means that you're going to pull I out and leave the number inside. Okay, so I'm going to simplify each term. Here we go with this term here. I'm going to start here. So that gives me I square root 3 times 2. Yes? Square root of 4 is 2. I simplified that part and that part. Plus, this would be 3 times I square root 2 times 3I. So that is this term. I simplified each part. The 3 comes down. This becomes I square root 2. This becomes I, and the square root of 9 is 3. Next one. I get I from the negative, and the square root of 16 is 4. At the end, simply just 4. So I'm going to go ahead and simplify these first two. All right, this first term becomes 2I square root 3. This next term becomes 9I squared root 2. So that's going to become a negative 9 root 2 plus 4I plus 4. Now, I can't combine any of that. There are ways the book kind of brings out what's in common. I'm not even going to bother with that. None of that can be added together, but I will write the real part first. So I'm going to group my real parts together. So 4 minus 9 root 2, right? This is my real. Plus, I'm going to group my imaginary. So 4i plus 2i root 3. And so that is, I'm just grouping the real, grouping the imaginary. Okay? So that's 5.6. 5.d is the ratio of similar figures, and I honestly didn't go, I'm not really going to go over it. So 5.c, I'm just going to kind of skip. It's just the ratio, you can do it, of areas of similar figures. Okay, which just equals the scale factor. I don't think it's worth doing a whole problem. It's just the scale factor squared. So if the ratio of the smaller to the larger, so if the example, if the ratio was 1 to 3, then the ratio of area would be 1/3 squared, which equals 1/9. Really, really simple part of this section. I'm not going to spend a ton of time of it. 5.d, I'm only going to do one problem. Don't worry, I won't torture you. So 5.d is on finding the diagonals of figures. So a squared plus b squared equals c squared. We know that, but that is review. So number 7, I'm going to draw a 3-dimensional figure because I'm amazing. And then I'm going to give you some information similar to what the book will do. So first I'm going to title this corner right here is A, this corner right here is B, and this here is C. Okay? I'm going to tell you that the length of this part here is 2, from here to here is 3, and from here to here is just M. Why would they do that to us? I don't know. All right, and they want us to find the length of AC. So to find the length of AC, I'm going to be working with diagonals, okay? And so hopefully you can see that. So if I draw this triangle, Mr. Royal totally interrupted us, you guys. And I wish I could pause it, but I can't. Want me to come by your office in a second?
Yeah, whenever you can.
Okay. I tried pausing it one time, and it just stopped it, and I couldn't open it back up. All right, so I'm going to draw the triangle that they're asking for. They want AC, and so I hope you can see that that would be, here would be, this is what they're asking for, if you can see that triangle. Okay, they're wanting to know this value here. Okay, so I'm going to label the pieces I do have. I know that this is M, because if this height here is M, then so is this one. I don't know what BC is. Okay, so here is AB, and here is BC. I don't know what that is, but I bet that if we redrew this, BC should be, this would be 2 and this would be 3. I hope you can visualize that. Like I know, here's the triangle right here that I drew here. And if this is 2, then I know this is 2. If this is 3. So to find BC, this length here would be 2 squared plus 3 squared equals, you know what, I'm just going to label this as, so that it makes sense. This is BC squared. So 4 plus 9, 13 would equal BC squared. So BC equals the root of 13. So now I can find this. Okay. So now I have something I can actually work with. So I'm looking for this here. So I would write, I know that M squared plus the square root of 13 squared equals AC squared. So that would be 13, I'm going to put this in order, plus m squared equals AC squared. I would take the square root, so AC equals the square root of 13 plus m squared. And I can't simplify it any further. That would be the answer. So if you get a problem like this, please try to envision what they're asking for and to write it down. So for this homework lesson, you're going to skip 10, 24 through 26, and 29. Thank you. See you guys later.